We were using properties of determinants to come up with formulas for calculating a determinant. We already did the one by one, and it was simple. It's just whatever the element of the matrix is, that's the determinant. For a 2 by 2, we had the little x. It's the product of the main diagonals minus the product of the off diagonals. And I said that was worth memorizing. When we came up to 3 by 3, you got this mess down here. And the point was the properties led to a formula. But at this point, someone started coming up with algorithms that made this, that was a way to compute this thing. You don't want to memorize this. And that leads us to expansion by cofactors. So let's define what cofactors are. First, let's define a minor determinant. Here's the notation, M sub ij. It's the determinant of the matrix left after you remove row I and column j. So if this is your beginning matrix, the M11 term, here's 1, 1. Get rid of that row and that column. You're left with these guys, 2 minus 1, 7 minus 4. M12, here's the 1, 2. Get rid of that row and that column. You've got 1 minus 1, 5 minus 4. There you go. So that's how you come up with the minor determinants. And by the way, you started out with the 3 by 3, you get 2 by 2s. You can use that little X formula to find these guys. And what is a cofactor? Well, it's just the determinant, this minor determinant, multiplied by the correct sign. Here's one way to describe it. It's minus 1 to the I plus j. So if I plus j is even, you get plus 1. If I plus j is odd, you get minus 1. It's plus, it's an even number, odd if it's an odd number. Another way to memorize it or view it, and this applies to any size matrix, start out with a plus at this top left term here, the 1, 1 term, and then alternate signs going either strictly left or strictly up or down. Strictly left and right or strictly up and down, not diagonal. Anyway, here's examples of some of those minor determinants and the cofactors there. So let's look at this guy and let's calculate not all of the cofactors. Let's do the 1, 1 term. The 2 minus 1, 7 minus 4. Minus 1 to the 1 plus 1. So that's a plus. So I don't have to change the sign. I can calculate that term. Minus 8 plus 8. Let's see, the 1, 2 term. It'll be 1 minus 1, 5 minus 4 for that part. But 1 plus 2 is odd, so there's going to be a minus there. Anyway, that's how you calculate cofactors, minor determinants and cofactors. Here's how you determine or find the determinant. You expand by those cofactors. Let's see. And you expand by a particular row or a particular column. We'll expand this guy by row 1. What does that mean? Okay, let's go across. 2, 6, 1. The 2, the minor determinant is, let's see, 2 minus 1, 7 minus 4. And it's 1, 1. 1 plus 1 is even, so no sign change. And I multiply by the 2. It's this 2 times that cofactor. Now, the second one, it's going to be that 6 times the cofactor, 1 minus 1, 5 minus 4. That was the 1, 2 term. 1 plus 2 is 3. That's odd. So I have a minus sign. Then finally, this guy, times 1, 1, 2, 5, 7. And that was the on 3 term, 1 plus 3 is 4, that's even, so no sign. I calculate these 3 determinants by that X rule and do that arithmetic, I got minus 11. You do it with any row or column. Here I'll expand by column too. So this 6, I'm going to have a minus sign, a plus sign, and a minus sign. I already know that. So minus, plus, minus. The 6 is going to be 1, minus 1, 5, minus 4. The 2 is going to be 2, 1, 5, minus 4. And the 7 is going to be 2, 1, 1, minus 1. Again, I can calculate each of these determinants, do all that arithmetic, I get the same answer. That's how to expand by cofactors. I think I'll stop there for this video. By the way, that's all in my NMath A course, where I probably covered more slowly.